Hello everyone, very good evening and welcome to the BYJU'S exam prep, the most comprehensive app for all competitive exams. Let me know that sound quality, picture quality, everything is fine. Yes, please. Yes guys, now we are going to start what that is the analog network digital, that is second session on KCL, KVL, mesh analysis and what nodal analysis. Yesterday I have given you the idea about the basics of the network. Now I am going to discuss what next stage of the circuit theory or network. Guys, tell me sound quality, picture quality, everything is fine. 1 minute. A very good evening, Naveen Kumar and Sri Sweta and Satyendra or Gunjay Naveen Kumar again. Yes, now everything is fine then. Guys, remember, already I have given now, once you will get the command over the network, then all the core subject will become easy for you. For electrical students, for example, machine, power system, power electronics measurement. And for electronics student, you will be able to solve the questions from what analog, questions from the EMFT and so on. Okay, first of all, get the command over the circuit theory or network. Kirchhoff's current law, Kirchhoff's voltage law, mesh and nodal analysis. In this session, I will also discuss supernodal analysis and supermesh analysis with some examples. Without any delay, now I am going to start this session. So guys, we are going to start what in BYJU'S Premier League, that is what BPL series, that is what YouTube plus app series. You have to attend the session on YouTube. We will cover the theoretical part on YouTube. Then we will arrange what quiz, right, on the same time, right? So that is, you can join and you can enjoy the series and you have to give the answer for all this question. We are going to start as early as possible, guys, to subscribe our channel. Second, now at 7:30 p.m. just in between the session, Rakesh Talreja sir will start one workshop for how to ace GATE in 8 months. Okay, so as you know the profile of Rakesh Talreja sir, MTech from ISC Bangalore, AIR 9 in GATE, 12 plus years of teaching experience, and this is a very important workshop for you. Just 7:30 p.m. Please note the time and register yourself for this particular workshop. Okay, then this is my introduction, guys. Myself Sanjay Rathi. I am an ex-IES and I am having 22 years of teaching experience. These are my ranks in engineering services exam that is conducted by UPSC AIR 16 and AIR 21, and I have trained more than 1 lakh students for these competitive exams, guys. Now what about your experience, everyone? Tell me, right? So what about your preparation is going well for GATE 2024 and you are focusing only on GATE 2024 or what engineering services exam or both or all other competitive exams? Now, yesterday I have given you the idea about basics. Basics means what is the charge, what is the current, what is the voltage across the capacitor, what is the current through the inductor, series connection, parallel connection of the elements. Okay, now before that class I have given you the idea about the standard textbook, about the syllabus and important topics from network, analog and what digital. Watch that session, network, analog and what digital, all the standard textbook, what are the important topics and last 5 years weightage, how many numbers, average of that. Okay, you will get the idea about that for electrical and electronics branch. Now guys, normally when we are talking about the circuit theory, everything is fine. First of all, inform me, everything is fine. Okay, then give me the comments if everything is fine, then you can send the emoji also. Then we have to deal with the what three things: node, branch and what loops. So node, branch and loop, that for example in this case it is node, it is a common node, right? Then this is called branch. This is the branch, first branch, this is the second branch, this is the third branch and this is the fourth branch, and it is a closed loop. Node is the point of the connection between the two or more branches. This is the point of the connection. Second, loop is any closed path in a circuit. You can also choose this loop as a closed path. And then we are having the branch and node. A branch means what? Any single element is connected to that particular branch. For example, This is a branch because one resistor is connected. This is a branch, one battery is connected. This is a branch, one resistor is connected. This is a branch where one resistor is connected. Okay, so that is the simple definition of branch, node and what? Loops. Then guys, what is the relation between them? So this is the relation. B is the number of branch, L is the number of loop, independent loops, and N is the number of node, and 1, that is the number. Then B is equal to L plus N minus 1. So I will give the description of this formula. Two or more elements are in a series if they exclusively share a single node and consequently carry the same current. What we are saying that any two elements are connected in series. For example, these two resistors are connected in series. They are connecting through a single node and they are having the same current. Same current will flow. Then we are saying that these are in series. Similarly, two elements are connected in parallel when they are having the same voltage. Same voltage, not the same current, same voltage. And these two nodes are common. Node number 1 and node number 2 are common. Node number 1, node number 2 is common. Then we can say these two elements are connected in parallel. It may be capacitor or it may be inductor or it may be what? Any other thing. Okay, battery, voltage source or what? Current source. So series connection and parallel connection. How we can find the equivalent resistance? In a previous class I have given you the idea about that. What is the current division rule? What is the voltage division rule? Already I have given you the idea about that. Now time to solve the mesh analysis and super mesh analysis. So you have the idea about the Kirchhoff's law. Once you want to apply the mesh or super mesh, nodal or super nodal, first of all get the idea about the Kirchhoff's law. So that is given by G.R. Kirchhoff, and there are two laws, KCL or what? KVL. KCL, KVL. Kirchhoff's current law, Kirchhoff's voltage law, and that about the history of that. Okay, you can go through that. No one is going to ask you this question, but that is important for just the general knowledge. Then along with the Ohm's law form the basis of the circuit theory. This is very, very important. Kirchhoff's law along with the Ohm's law. What is the Ohm's law? V is equal to IR. We are using the formula. And Kirchhoff's was also credited with the Kirchhoff's law of radiation. That is about the theory. Then guys, now I am going to describe one by one. First of all, give me 1 minute. Yes. Kirchhoff's current law. Hi Vinod, how are you? Satyendra. Now tell me everything is fine. Okay then. Now guys, KVL or KCL. These are the two important laws. Yes, I will give. In this session you are going to get the answer with numericals. Where we have to apply the KCL, where we have to apply the KVL and so on. I am going to give you the idea about that. For example, KCL. If you want to apply the KCL, let this is a one node here. Or in this one node, there are 4 branches are connected. 1, 2, 3 and 4. Some currents are incoming towards the node and some currents are outgoing. Then always remember, according to law of conservation of charge, it is based on law of conservation of charge. That is, charge can neither be created nor be destroyed. Then simply you have to apply the Kirchhoff's current law. Means sum of incoming current is equal to sum of outgoing current. So what is the incoming current? I1. What is the incoming current? I2. So what is the outgoing current? I3 and I4. Right? So at particular node we can't store the charge. So incoming is equal to what? Outgoing. Incoming is equal to what? Outgoing. That's why I1 plus I2 is equal to what? I3 plus I4. That is, the incoming is equal to what? Outgoing. This is called simple Kirchhoff's current law. What is important thing about that? It is based on law of conservation of charge, right? Then second, Kirchhoff's voltage law. Kirchhoff's voltage law means it is based on principle of conservation of energy. Energy can neither be created nor be destroyed. Then guys, in any loop, in any closed loop, the summation of the voltage is equal to what? 0. That is what KVL. So that is, if suppose that is a loop, from when we are moving from this point to this point, like this is the plus minus, this is the plus minus V2, this is the plus minus V3 and that is the V4. Then when we are entering into this loop, you can write this is the plus, it will become V1. Again we are getting the plus, it will become V2. Again we are getting the plus, it will become V3. But once you are getting the minus, for example here you are getting the minus, it will become minus V4. What is the summation of the voltage? That is equal to what? 0. So when we are moving in a loop, this is the plus V1, plus V2, plus V3 and finally minus V4. The summation of this total voltage will become 0. That is called what? KVL, Kirchhoff's voltage law. So that is the two basic law, KVL and KCL, guys. Right now, once you will, but for to apply the KVL, there should be the closed loop, and to apply the KCL, there should be what? Node, and there are multiple branches, some incoming currents and what? Outgoing currents. Okay. In case of nodal analysis, we are applying the KCL, or in case of mesh analysis, we are applying the KVL. What is the nodal analysis and mesh analysis? You will get the idea. Then, what is the, first of all, I am going to explain you the mesh analysis, because in number of numericals you have to apply this mesh analysis. Now, what is mesh analysis? It is based on systematic application of KVL. Systematic application of KVL. And there are two mesh analysis. One is what? Normal mesh analysis. Then second one is super mesh analysis. Now, we will discuss both type of method with examples. It is also known as loop analysis because we are going to apply the KVL in loop. It is also known as mesh current method. So what is the mesh current method? You will get the idea. It is used to find the unknown currents in particular branch. Unknown currents in particular branch. Okay. I am going to take very important example. It is visible to you, everyone. It is visible to you, this diagram. Okay. Now, first of all, nothing is given here. Now, how we can apply the mesh analysis to find the current? For example, if you want to find the current through the R6, if you want to find the current through the R6, then this is a loop. First, second, third. These are the independent loop and these are called what? Mesh. So in this mesh, we can assume a mesh current that is given by, this is a loop and here we are assuming one current that is called I1. Again here current, we are assuming one second current I2. Again we are current I3. So these are called mesh current I1, I2 and what? I3. Now, watch these guys. If this is the current I1, this is the current I2, this is the current I3. But remember, that is not the branch current. That is called mesh current. When we are saying that mesh current, what is the difference between the branch and mesh current? Watch this. If the mesh current or loop current is I1, so what is the branch current for this branch? This is the I1. What is the branch current for this? This is the I2. Only the I2 will flow. And what is the branch current for this? I3. What is the current here? I3. But when I am talking about this branch, what is the current in downward direction according to this I1? What is the current in upward direction? I2. So if suppose I am going to take the current in downward direction, it will become I1 minus I2. So that is the difference between the branch current and mesh current. So what is the branch current here? I1 minus I2, and what is the mesh current? I1 and I2. These two currents are in opposite direction. So what is the current through this R2? I1 minus I2. Similarly, if you want to calculate the current in upward direction, then it will become I2 minus I1, because it is I1 minus I2, then upward direction I2 minus I1. Similarly, in this branch, what is the downward currents? I2 minus I3. And what is the upward current? I3 minus I2. Okay. Now, so that is the difference between the branch current and what? Mesh current. Then how we are going to write the equations here? If you want to write the equations, then this is the branch. First of all, apply the KVL in this loop. Apply the KVL in this loop. Very simple one. When you are going to apply the KVL in this loop, KVL means what is the voltage here? Minus V. You are entering through the minus. This is the plus. This will become minus V. This is the plus minus. what is the voltage here? What is the drop across the resistor? I1 R1, because what is the branch current? I1 R1. Then when we are entering here, what is the downward current? This is the plus, this is the minus. What is the downward current? I1 minus I2 into R2. I1 minus I2 into R2, and is equal to what? 0. Is equal to 0. Now arrange this equation. It will become I1 R1 plus R2 minus I2 R2 is equal to what? V. Is equal to V, and that is called the equation number 1, and this is the equation number 2. So what is the analysis? First of all, assume the 3 mesh current I1, I2 and I3. Then write down the KVL in the first loop and move in the direction of current I1. This is the plus minus, this is the plus minus. But what is the current in this branch? I1 minus I2. Write down this equation and arrange it, and that is called the first equation. Second equation will become in this loop. What is the current here in the direction of the I2? The drop is I2 into R3. What is the drop in the downward direction? What is the current in the downward direction? I2 minus I3. So it will become I2 minus I3 into R4. And when we are moving in the direction of I2, always this is the plus, this is the minus. And what is the current in upward direction? I2 minus I1. What is the current in upward direction? I2 minus I1. Now move in this loop, second loop. Just I am going to highlight it. This loop, second loop. When we are moving in the direction of I2, you can write the equation I2 R3 plus I2 minus I3 into R4 plus I2 minus I1 into R2 is equal to 0, because there is no active source, there is no battery. Directly you can apply. Then arrange this. When we are going to arrange this, you will get I2 R3 R2 plus R3 plus R4 minus I1 R2 minus I3 R4 is equal to what? 0. Is equal to 0. That is called what? Second equation. I will give you the shortcut also. I will give you the shortcut quickly how we can write the equation. Then third equation. Third loop. Watch this. Third loop. What is the direction? I3. Because for this loop mesh or this loop, the mesh current is I3. To write down the direction of I3. Plus minus, and this is plus, this is minus. So what is the current in upward direction? I3 minus I2. So what I can write? I3 into R5 plus I3 into R6, because these two are connected in series. And in upward direction, I3 minus I2 into R4. I3 minus I2 into R4 is equal to 0. Arrange this equation. You will get the I3 common. R5 plus R6 plus R4 minus I2 R4 is equal to what? 0. So guys, there are three important equations. First, second, and that is the third equation. Guys, we are having the three unknowns and we are having the three equations. So you can solve the three unknowns by solving these three equations. You can use the Cramer's rule, or you can use any rules to find the unknown values I1, I2 and I3. If suppose the current through R6 is required, then you have to find the I3. If suppose the I2 is required, then you have to find a current through the R4. If the current through R4 is required, then you have to find the I2 and I3. And then what will be the current? I2 minus I3. If the current through R2 is required, you have to find the I1 and I2. Then in a downward direction, the current will become I1 minus I2. So these are the three important equations. Once you are able to find the three important equations, game over. Okay, question. We can solve these three equations. Is there any shortcut? Right? First of all, we are writing this equation, then we are arranging. Then again we are writing this equation, then we are arranging. Then we are writing this equation, we are arranging. So I am giving you the very simple method. Now please try to solve with this method. Right guys? What is the method here? Just very, very easy one. Directly we can save our time. Try to understand. Then guys, no need to write this equation. Directly you can write the second equation. How? This is called inspection method. What is the inspection method here? First of all, apply the mesh analysis. Let this is the I1, this is the I2, this is the I3. Then this is the first mesh. So I1 will flow through what? R1 and R2. And what about the I2? I2 is in opposite direction to I1. This is going downward, this is going upward. Then you can directly write I1. I1 will flow through the R1 plus R2. What about the I2? That is in opposite direction. And which register is common? R2 is common. Is equal to which battery is connected here? V. And what is the polarity? When the I1 is entered through the minus, leave the plus. Then it will become plus V here. Because it will deliver the energy. Because that battery will deliver the energy. When the current entered through the minus, leave the plus, means that battery will deliver the energy. So in yesterday I have given, and that's why directly you can write the first equation. Similarly, for I2. For I2, you can write I2 is common for what? R3, R4 and R2. So you can directly write this equation. I2 multiplied with R2, R3, R4, R2 plus R3 plus R4. What about the I1? I1 is moving in opposite direction. That's why you have to write the minus I1 R2. So you are writing the minus I1 R2. This is the, again, what is the I3? I3 is also flowing in opposite direction to the I2. And that's why you have to write the R4 minus I3. R4 minus I3. Okay. So this is called what? Inspection method. Directly watching the diagram. No need to write this equation. No need to write. No need to write this equation. Simply I2 R3 plus R4 plus R2 minus I1 R2, because these are opposite direction, minus I3 R4. Similarly, for this loop, you can directly write I3 into R4 plus R5 plus R6. What is I2? It is in opposite direction. You can write minus I2 R4. Is there is any battery? No battery. That is equal to what? 0. That is equal to what? 0. That is not another method. This is again a mesh analysis. But inspection. This is called inspection method. This is called what? Inspection method. Just we are watching the circuit and we are writing the equations. So guys, in a previous case, you have to write the 6 equations. 1, 2, 3, 4, 5, 6. But in this, we have to write only what? 3 equations. 1, 2 and 3. Only 3 equations. 1, 2 and 3. So in this way, we can save our time. That is called inspection method. Then you have to solve these equations. You have to solve these equations. We will solve the numerical. That is the one method. Now guys, what is the super mesh analysis then? Super mesh analysis, guys. Super mesh. Again theoretical, then we will solve numerical on that. Super mesh analysis means, suppose if we are having one current source in between 2 loops. For example, we are having any current source between loop number 2 and loop number 3. Then remember, we can't apply the KVL across the current source. Right? We can't apply the KVL across the current source. Then suppose you are choosing the 3 mesh current. For example, this is the mesh current 1. I1. This is the mesh current I2. And this is the mesh current I3. Then this is the I1, this is the I2, this is the I3. What is the, this is the current in downward direction. So what is the current in the downward? Already I have given what is the branch current. This is going downward, this is going upward. So what is the branch current? I1, I2 minus I3. So I2 minus I3 is nothing but I. This may be 5 ampere or 2 ampere. That constant value of the current, it is given in the circuit. You can't apply the KVL with this. So first of all, find what is the branch current according to in the terms of what? Mesh current. So I2 minus I3. So you will get first equation, I2 minus I3 is equal to what? I. That is given in the question. This is a constant value. It may be 1 ampere, 2 ampere, 5 ampere. Now you can apply the KVL in this loop. Just like a mesh analysis, you can write, first of all, you will write I1 R1 plus R2 by inspection method. You can write I1 R1 plus R2 minus I2 R2, because it is in opposite direction, is equal to what? V. Just like a previous question, we can write V. This is the first equation. Second equation, already we have the second equation. I2 minus I3 is equal to I. What about the third? That is called supermesh analysis. In this case, you have to apply the loop. That KVL is valid for what? Kirchhoff's voltage law is valid for any closed loop. This is also a closed loop. So you can write the KVL in this direction. When we want to write the KVL in this loop, then remember, this is plus, this is minus. What is the current here? I2. This is plus, this is minus. What is the current here? I3. This is plus, this is minus. Again, current is I3. Move here. This is plus, this is minus. What is the current in upward direction? I2 minus I1. I2 in upward direction, I1 in opposite direction. So this is the branch current. And now in this loop, you have to apply the KVL. And that is called what? Supermesh analysis. What is the supermesh analysis? It will become I2 into R3. Because in this branch, the current is I2. Then it will become I3 R5 plus R6. Why? Because both are connected in series, and R5 and this is the R6. These are current will flow R5 and R6. Then this will become what? I2 minus I1 into R2. I2 minus I1 into R2. R2 is equal to 0 because there is no battery in this loop, and that is called what? Supermesh analysis. We are concluding the two loops, and we are writing one KVL. So guys, we are having the three unknowns. What are the unknowns? I1, I2 and I3. To solve three unknowns, there should be three equations. So there is the three equations. Yes, this is the first, this is the equation, this is the first, this is the second, and that is the third equation. You are getting the three equations, three unknowns. Now you can solve it. That is called what? Supermesh analysis. Are you ready to solve some questions, guys? Yes, please. This is the supermesh analysis. And how we are going to write? When we are going to apply, when there is a current source between the two loops, then we can't apply the KVL. Then we are applying the KVL in this closed loop. And we are using the branch current I2 minus I3, that is equal to I. Okay. Then, if you are ready to solve then one question, then I am going to give you one question here. This is the question. Okay. That. Tell me, mesh analysis or supermesh analysis? Everyone. Mesh analysis or supermesh analysis? Arjun, what is this? Okay. Then this is the question given, and you have to find the I naught. This is the I naught. It is in the downward direction. I naught, it is given in the downward direction. You have to find the current here. There are three options, right? Then, guys, we have to apply the mesh. And this is the 2 ampere current source is given in between these two loops. If the 2 ampere current source is given and the battery of 20 volt it is given. Battery of 20 volt it is given. Okay. Then, yes. One minute. 50 volt it is given. Okay, no problem. 50 volt it is given. This is battery of 50 volt it is given. Then tell me how we can find. Then we have to apply what? Satyendra has given the right answer. That is, we have to apply the supermesh analysis. So what is the supermesh analysis? Mesh analysis. Yes. Supermesh analysis. Why we have to apply the supermesh? Because we are having a current source here. Now we are assuming that there are 3 loops, that this current is I1, this is called mesh current. You can choose according to your direction, but normally we are choosing in clockwise direction. You can also choose in anti-clockwise direction. This is the current I2 and that is the current I3. Now if you are choosing the current, then always remember what is the current in this branch? I1 minus I2 in downward direction, because I1 in same direction, I2 in opposite direction. What is the current in this branch? Because I0 is required. In downward direction current is I1 and in upward direction current is I3. That is the first equation. You have to find the I1 and I3, then you can find the I0. Now what is the current in this branch? In this direction current is I2, in opposite direction current is I3. So what is the current in this direction? I2 minus I3. And that's why second equation will become I2 minus I3 is equal to 2 ampere. This is the second equation. Now because this is not an equation, I1 minus I3 you have to find. So it is the first valid equation. Then you have to apply the mesh analysis for the 2 loop. Any chance to cancel the GATE course after 65 days from? Arey, I have no idea about that. You can mail. You can mail for that. Okay, Vinod. Then suppose that is the case, then this is the mesh, first mesh. So when we are applying the first mesh, what will be the equation? Then this is, you can write minus 50 is equal to, I am just giving you how to write the KVL. What is the downward current? I1 minus I2. This will become plus, this will become minus, and what is the current? I1 minus I2. I1 minus I2 into 10. And what is the current in the downward direction? This is plus, this is minus. What is the current in the downward direction? I1 minus I3 into 5. First equation will become I1 minus 50 plus I1 minus I2 into what? 10 plus I1 minus I3 into what? 5. And then is equal to 0. Now you can solve 10 plus 1, 15 times of I1 minus 10 times of I2 minus 5 times of I3 is equal to what? 50. Can you directly write this equation by using the inspection method? Yes, we can directly write, because this I1 will flow through 10 and 5. So 10 plus 5, 15 I1. What about the direction of the I2? It is in opposite direction. That's why it will become minus 10 times of I2. And it is also in opposite direction to I1. It is downward, it is upward. Minus 5 times of I3. And current entered through the negative terminal of the battery. Current entered through the negative terminal of the battery. And that's why it will deliver the energy is equal to 50. Is equal to 50. Directly you can write this equation by using the inspection method. Okay, so you can save your time. This is the first equation. Then how we can write the second equation, guys? So let's try to understand. Now the second equation, that is already I have printed here. Try to understand. Now that is the first equation. Second equation. For second equation, you can go through this loop. Complete loop, because it is a supermesh analysis. Supermesh analysis in this direction. So when I am moving in the direction of the supermesh, it will become, first of all, it will become 2 times of I2 plus minus 2 times of I2. Then it will become, what is the current in this loop? I3, 1 time of I3. This is I3. When I am moving in opposite direction, this is plus, this is minus. And what is the current in upward direction? I3 minus I1. Then it will become 5 times of I3 minus I1. And when we are moving in this direction, again in upward direction, this is plus, this is minus. And what is the current in upward direction? I2 minus I1. It will become 10 times of I2 minus I1. Always remember, you have to apply the proper KVL. I2 minus I1 is equal to what? 0. You will get this equation. And then arrange it. When I am arranging 10 plus 2, 12 times of I2 plus 5 plus 1, 6 times of I3. 5 plus 1, 6 times of I3. This is over, and then 5 and 10 minus 15 times of what I1 is equal to 0. And that is called the second equation. So how many equations we are getting? This is the first one. I2 minus I3 is equal to 2. This is the second equation, and that is what? Third equation. And that is the way, in this way we can apply the supermesh analysis. Now guys, it is assignment for you to solve these three equations. I am writing the three equations. Just I am going to give you the equations. Yes. So already we have got the three equations. What are the equations? First, I2 minus I3 is equal to 2. Second equation, this is the second equation, 15 times of I1 minus 10 times of I2 minus 5 times of I3 is equal to 50. Third equation, 12 times of I2 plus 6 times of I3 minus 15 times of I1 is equal to what? 0. First, second, third. From this you have to find the I3 and I1, and then finally you can find the I0, I1 minus I3. You can also use Cramer's rule to solve these equations. Cramer's rule to solve this equation, guys. Okay. So just tell me, everyone, please give me the answer in comments box. Now you are comfortable how to write the supermesh analysis equations. I am talking about the equations. This is a lengthy question, but how we are going to write the equations by using the supermesh analysis, that is very, once you will get the equations, it is very easy to solve the equation and get the value of the I1, I2 and I3. Okay. And second thing, directly by the inspection you can also write, because we are moving in the direction of I2 and I3, you have to take the positive value. I2 will flow through what? 2 and 10, so it will become 12 times of I2. I3 will flow through what? 1 and 5, that's why it will become 6 times of I3. What is the direction of I1? Opposite to the I2, that's why minus 10. Opposite to I3, minus 10, minus 5, minus 15 times of I1. Directly you can write this equation with practice. No need to write this equation. With practice you can directly write. Okay, that is the case. Right? Okay, it's rock. Yes, CS follow. CS means what? Civil, computer science branch, guys. If you want to give the GATE examination with electronics or electrical branch, then that is for you. Otherwise, it is for electronics, electrical and instrumentation branch. Okay. So this is called supermesh analysis. Okay. And that is the solution is available, guys. You can take the screenshot and you will finally you will get this answer. Finally you will get this answer. Please check my calculation. Finally you can take a screenshot. But guys, okay, 1 minute. By screens, after taking the screenshot, try to solve this question. इक्वेशन मैंने लिखवा दिया है. अब आप बोलोगे कि सर ये भी हम लोग वर्क करके दिखा दो, तो इक्वेशन वगैरह सॉल्व आप कीजिए तभी एग्जाम निकलेगा आपका. ये तो बस मैश एनालिसिस कैसे लिखा जाता है इसका हिंट है. अब आते हैं नोडल एनालिसिस में. नोडल एंड सुपर नोडल एनालिसिस. ओके, नोडल एंड सुपर नोडल एनालिसिस गाइस. एंड देन वी विल सॉल्व सम क्वेश्चंस. ओके, देखो अब आती है बात जब नोडल एनालिसिस की ना, तो ये देखो नोडल एनालिसिस. नोडल एनालिसिस इज बेस्ड ऑन सिस्टमैटिक एप्लीकेशन ऑफ किरचॉफ्स करंट लॉ, KCL. It is also known as node voltage method. Node voltage method. It is used for finding the node voltages. If you want to find the branch current, then you have to use the mesh analysis. If you want to find the node voltages, then you have to use the KCL, Kirchhoff's current law. It is based on law of conservation of charge. What is the nodal analysis? For example, let this is the circuit. There are nodes. This is called reference node. This is a common node and that is called reference node. So sometimes ground is not given, then again you can take it what as a reference node, let it is 0. Then this is the node number 1. You can assume the voltage like it is the V1. Let this voltage is V2. let this voltage is V3 and so on, because there are three this nodes and one, that is there are four nodes, there are four valid nodes in this diagram. So we are assuming that this is the node number 1, node number 2, node number 3, node number 4, node number 4 as reference node, and this is the V1, this is the V2, and that is the V3. Now guys, try to understand. Number of students are confused how to apply the KCL, confused with what direction of the currents. So actually, what is the normal practice? When we are applying the KCL at particular node, for example this node, so it is visible that this is the incoming current. Now what is the outgoing current for this node? Let this is the outgoing current I1, let this is the outgoing current I2. I am just talking about this node only, focus on this node only. So what is the KCL? Incoming current is equal to outgoing current. So what is the incoming current I? That may be the 5 ampere or 6 ampere, it is given in the question. V1 minus 0 by R1, V1 by R1 plus V1 minus V2, because the current will flow in this direction, V1 minus V2 by R2, and that is called KCL, use of KCL, Kirchhoff's current law at the node number 1. This is the equation number 1. Okay, so that is the KCL. In a second node, what we are doing, only focus on the second node. Now let this current is outgoing current, let this is the Ix, this is the outgoing current Iy, this is the outgoing current Iz. Now when we are focusing on this node, there are three outgoing current, Ix, Iy and Iz. According to the KCL, sum of the outgoing current is equal to 0, because there is no incoming current. Sum of the outgoing current Ix plus Iy plus Iz is equal to 0. Then how we can write the Ix? Always flow from higher potential to lower potential. Means we are assuming V2 as higher, V2 minus V1 upon R2. V2 minus V1 upon R2. What is the Iy? V2 minus 0 by R3. This is R3. That is V2 by R3. And what is the Iz? Sorry, Iy is this one. So Iy V2 minus V3 by R4. Iy is V2 minus V3 upon R4. This is the Iy. And what is the Iz? V2 minus 0 by R3. And what is the outgoing incoming current? 0. And that is the KCL, Kirchhoff's current law at node number 2. All are the outgoing current, Ix, Iy, Iz. So that is the normal practice. Sum of the outgoing current is equal to 0. But in this branch, already one incoming current is given. That's why we are writing incoming is equal to outgoing. Similarly, when we focus on the third branch, third one, watch this. You can assume that this current is IP, this current is IQ, this current is IR. All are outgoing current. So you can write the sum of what? IR is equal to 0. Again, we are assuming the outgoing current from the node number 3. So node number 3, what is the IP? V3 minus V2 by R4. It will become V3 minus V2 by R4. So we are writing in terms of V3. So V3 minus V2 by R4. V3 minus 0 by R5. Plus again V3 minus 0. It is again reference. So V3 minus 0 by R6 is equal to what? 0. So we are getting the three equations. First equation, second equation and third equation. And that is the way. That is the way to apply what nodal analysis or KCL. So number of students are confused that sir, why we are taking the outgoing current or incoming current. Here, if you are assuming that this is the outgoing current, suppose this we are assuming that this is the V2 minus V1. We are writing the equation, but it may possible that V2 may be less than V1. So there will be the current that will flow from V1 to V2. If the V2 is greater than V1, then definitely the current will flow from V2 towards what? V1. But it doesn't matter. When we are assuming that all the currents are outgoing current, then sum of outgoing current is equal to what? 0. That is the way, in this way we can write the KCL, and that is called what? nodal analysis. So we are applying the nodal analysis at 3 nodes. Okay. I think now you are comfortable with this. Finally, supernodal analysis, guys, where we are going to apply the supernodal analysis. Supernodal analysis means when we are having any voltage source between 2 nodes. For example, that is the diagram. This is the simple current V1, V2. That is the third. This is the what node? This is the second node. This is the third node. This is the fourth node. This is the reference node. This is the common node. We are having the voltage source between V2 and V3. Then we can't apply the nodal analysis directly, right? Because we can't apply the Kirchhoff's current law with voltage source. Then if there is any voltage source between the 2 nodes, then first of all you have to write, this is the positive terminal here, battery positive terminal, negative terminal, means V2 minus V3 will become Vx. The first equation will become V2 minus V3 is equal to what? Vx. Then at this node the equation will remain same. This is the I is equal to V1 by R1, V1 minus V2 by R2. That will remain the same. This is the equation number 1. I V1 minus 0 by R1, V1 minus V2 by R2. That equation will remain same. Equation at V4 will remain also same. What are the outgoing current? Like this is the IP, this is the IR, this is the IQ. Then again, what are the outgoing current? You can directly write the equation IP V4 minus V3 upon what? R5, V4 minus 0 upon R6, V4 minus 0 upon R7. That again it will remain same, is equal to 0. Again it will remain same. But what is the supernodal analysis? Supernodal means at these 2 nodes we have to write the KCL simultaneously. How we are going to write the KCL simultaneously? These 2 nodes. These 2 nodes. 1 minute. Okay. These 2 nodes. Then write the KCL at this point. What is the outgoing current? Let this is the outgoing current Ix. This is the outgoing current Iy. What is the outgoing current? I, right? Iz, and let this is the Iw. Then Ix plus Iy plus Iw plus Iz. Simultaneously we are applying the KCL at this point and KCL at this point. That will become Ix plus Iy plus Iw plus what? Iz is equal to 0. What is Ix? V2 minus V1 by R2. Iy will become V2 by R3. Iw will become V3 minus 0 by R4. And Iz will become V3 minus V4 by R5. That is the 0. And this is called supernode equation. We are considering V2 and V3. We are simultaneously considering the V2 and V3 and we are writing the KCL. So this is called supernode analysis. I think this is clear to you how we are going to write the equation. So directly first equation similar, incoming current, outgoing current, that will remain same, V4 will remain same, but third equation is what? V2 minus V3 is equal to Vx, and fourth equation is what? From supernodal analysis, this is the supernode. 4 unknowns are here. What are the 4 unknowns? V1, V2, V3, V4, and you have, when we want to solve the 4 unknowns, those are called node voltages. 4 equations are required. This is the 4 equations are required, guys. Okay. So that is what supernode analysis. Now this is the time for the homework, guys. Write down the equations only. Write down the equations and try to solve this question. Find a I naught with the nodal analysis and give me the answer in comments box. I am giving you the hint. This is the 10 ampere. This is the V1. This is the 2. This is the 3. This is the 1. This is the 20 volt battery is given between V2 and V1. V2 and V3. And that's why you have to apply the supernodal analysis, and first equation will become V2 minus V3 is equal to 20 volt. V2 minus V3 is equal to what? 20 volt. You have to solve. Then I am giving you the equation. What is the incoming current? 10. What is the outgoing current? V1 minus 0 by 3. That will become V1 by 3. What is the outgoing current? V1 minus V2 by 2. V1 minus V2 by 2. That is the equation number 1. This is the equation number 2. Now write down the already. This is the supernodal. Now this at these two nodes we have to apply the supernodal analysis. That's why it will become V2 minus V1 by 2. V2 minus V1 by 2. That is the outgoing current in this direction, Ix. Then what is the outgoing current? Iy. V2 minus 0 by 1. Then what is the current? Iw. V3 minus 10. If any battery is given, then you can write V3 minus 10 by 5. And then what is the Iz? Iz will become V3 minus 0 by 2. This is the sum of this current, this current, this current and that current is equal to what? 0, and that is called supernode equation. यहाँ पर हम लोग apply कर रहे हैं supernodal analysis. Now we are having the three unknowns. What are the unknowns? V1, V2 and V3, and we are having the three equations 1, 2 and 3. Try to solve these equations, three equations, by using the Cramer's rule or by any other methods, and give me the answer in comments box, guys, on my Telegram channel, that is Electronics by Sanjay Rathi. So I am just sharing the link with you. Please everyone join the session and give me any doubt, then please inform me. Any doubt, then give me the answer in comments box. You are enjoying the session, guys? Yes, please. So that is my address, Electronics by Sanjay Rathi. You can join my Telegram channel, right? So that you will get the notification about my classes, and you can post your answer there, and I will check if you are going to give the detailed answer for this question. Suppose you want to solve that particular questions, how to write the Cramer's rule and so on, then post your complete answer, detailed answer. I will go through the step by step, right, and I will check and I will inform you about your effort. Okay, so that is the case. Now and that is the homework again, second one. In the given circuit, the mesh currents I1 and I2 are. Already it is given. This is the 5 volt, it is given. This is the 6 ohm, it is given. 2 ohm, it is given. And that I2 it is given, and I3 it is given. And this is the 2 ampere, it is given. 1 ohm, I1, I2 and I3, 1 ohm. Okay. Check the answer, and what is the answer? You have to apply the Supermesh analysis in this loop and you have to give the answer. Okay, Supermesh analysis in this diagram. Try to solve this question. Again, it is a very easy and it is an objective question, guys. These answers are given here, and this is a MCQ type questions. Okay, then thank you for attending the session. You are on BYJU'S exam prep, the most comprehensive app for all competitive exams. Right, like the session, share the link of this session and subscribe our channel, because we are going to start very important session like what Trichopedia, Coffee with Concepts. Okay, and we are going to start very important series, that is the YouTube plus what app series. तो वो बहुत ही ज़्यादा beneficial होगी आपके लिए. YouTube में आप concept समझेंगे और app में आप quizzes solve करेंगे at the same time, guys. Okay, so tomorrow at the 7 PM again, I will take very important topic, that is what digital. I will start with the digital basics of, and then second thing, tomorrow morning at 11 AM. How many students are interested to solve the questions from analog for ISRO examination at 11 AM on BYJU'S exam prep app? First of all, install the app and then follow me and start join the 11 AM. I will share the link on my Telegram channel, that is Electronics by Sanjay Rathi, where we will discuss around 10 questions, 10 expected questions from analog for ISRO 2023. Okay then, thank you very much for attending the session. You are on BYJU'S exam prep, and you can scan this code to join our Telegram channels also. Okay then, thank you.